Let us start with introduction of matrices. Now, we have done determinants. Determinants we know is a representation of numbers which has a particular value. Matrices, however, they look like determinants but are very different from determinants. They are just the representation of numbers in the form of rows and columns. Determinants have some properties that matrices do not follow. Also, there are some type of matrices which are associated with determinants, but that cannot be said about all the matrices. Now, what are matrices? A matrix is an arrangement of various elements, that is numbers in the form of rows and columns, and unlike determinants, they do not have a particular value. Now, matrix is just an arrangement of rows, numbers in the form of rows and columns. A matrix looks like this. Just an arrangement in the form of rows and columns. In this particular matrix, we can easily locate that it has m rows and n columns. Just look at the first column. The first element being A11, second being A21, the last being AM1, indicating it has m rows and n columns simultaneously. Now, elements are represented in the same way as we have in the determinants, but they're very different from determinants. They do not have a single value which determinant have. Now, the important aspect of defining the matrix is its order. We define the matrix by its number of rows and columns. Clearly, this has m rows and n columns. So the order of this particular matrix is m by n, that is m rows and n columns. Aij is representation of a number which is in the ith row and jth column. So Aij, if this is an element of a matrix, it is in the ith row and jth column. So the matrix can be represented as Aij in the square bracket or having order m by n. Now let us look at types of matrices. Row matrix, as it is indicated by the word, it is a matrix having only one row and multiple columns. A row matrix looks like this. That is only one row having elements A11, A12, A13 and so on up to A1n. N represents, of course, the number of columns. So row matrix of the order 1 by n. The second matrix is column matrix. Again, a matrix having only one column and many rows, which looks like this. A11, A21, AM1, indicating there are m rows and only one column. Now again, there's a matrix called zero matrix or null matrix. Again, as it is indicated from the word, a matrix in which all the elements are zero. So all the elements being zero is called zero matrix or null matrix. So this is a zero matrix of the order m by n, that is, it is having m rows and n columns. So in a zero matrix, we can easily say that Aij is zero for all I and j, that is, each and every element of the matrix is zero. Now again, horizontal matrix, which is the fourth type of matrix. Again, taking from the word, a matrix which looks horizontal. That is, it has more columns than rows. So element of the type m by n, where m represent the number of rows, n represent the number of columns. Here n, which is the number of columns, is more than the number of rows, which is m in this case. Similarly, we can define vertical matrix as a matrix which looks vertical, that is, it has more rows than columns, or m is greater than n. A vertical matrix looks like this, having more rows than columns. Again, square matrix. This is the most important type of matrix that we'll be using in this chapter. A square matrix is a matrix which has equal number of rows and columns, that is, m is equal to n. So this has same number of rows and columns. It looks like a square because it has same number of rows and equal number of columns, n by n. In a square matrix, the elements with the same column and row are called diagonal elements, that is, elements of the type AII, that is, I is equal to j. In this case, these are the elements which are called the diagonal elements of the square matrix. A11, A22, A33, that is, elements of the type AII. Also for the square matrix, there is an important term called trace of the matrix. The trace of a square matrix is defined as sum of all the diagonal elements. That is, in this case, the trace can be defined as A11 plus A22 plus A33 and so on up to ANN.